Okay, so quick review from the other day. Okay, the 5 reaction types that we went over were synthesis, simple decomposition, combustion, single replacement, double replacement. Okay, those were the 5 that were in our notes from the other day. All right, so if I'm looking at question number 1 here, I'm starting out with a compound as my only reactant. My products are 2 elements. Okay, the 2 elements obviously that make up the compound. So what reaction type fits with a single compound breaking down into its 2 elements? Decomposition. All right, so that's our first one. Okay, so this is a decomposition reaction. Next thing I have to do is write this out in words. All right, this is a molecular compound. Okay, our reactant is a molecular compound, so I need to name it as such. It's going to be trinitrogen dioxide. All right, then I just draw an arrow, okay, to indicate that this is now going to the product side of the reaction. What's this stuff called? Nitrogen. Okay, just because it's a 2 doesn't change its name. This is how nitrogen is as an element. It's one of those special molecular ones that we talked about. Okay, so this is just going to be nitrogen plus oxygen. All right, so now it's written out in words. Last thing, I need to balance it. I should start generally with what's present in the largest number, because usually that will work in terms of getting something to balance out properly. Sometimes it doesn't, and we have to go back and forth a bit. Right? Right now, nitrogen is present in the largest number. It's a 3 on this side, but over here, it's a 2. Right? What's the lowest common multiple of 3 and 2? 6. Okay, so I need to get 6 nitrogens on both sides. That means putting a 2 here to get me 6 nitrogens, and a 3 here to give me 6 nitrogens on the product side. When I put this 2 here, though, it also applies to the oxygen. So how many oxygens are there? 4. All right, so what needs to go here? A 2. All right, and that's all there is to balancing. Okay, the hardest math you have to do in balancing is lowest common multiple. All right, that's all you have to do. Questions on number 1? Okay. For question number 2, okay, I have an element, in this case it's a metal, reacting with an ionic compound that's producing a different element, which is also a metal, okay, and a different ionic compound. Right? What kind of reaction is that going to be? That is a single replacement reaction. Okay, because in single replacement reactions, well, in all replacement reactions, we only have ionic compounds. Okay, in single replacement reactions, it's an element reacting with an ionic compound. All right, so writing this out in words, this stuff is calcium plus iron 3 chloride. And guys, when I put a question like this on a quiz or a test, that's the thing people will forget. Okay, they'll be concentrating on reaction types and balancing, and they'll forget the simple stuff like when things need a Roman numeral. Okay. All right, going over to this side, I now have iron as an element. Here's another mistake people make. They'll put a Roman numeral on that. Okay, what does the Roman numeral tell me about iron again? Yeah, what charge you're using, right? The how many electrons it's going to lose. When it's an element, has it lost any electrons? It hasn't. When it's an element, its number of electrons and protons are equal. Okay, it can't have a charge, so we don't apply a Roman numeral to an element. We only apply it in here when it's in a compound. But I see people over applying that rule often, okay, and they put a Roman numeral home when they don't need it. Okay, all right, and then we have calcium chloride over here. All right, now I need to balance. The only thing that's out of balance right now is chlorine, so I'll start with that. On the reactant side, there are 3, and on the product side, there are 2. We just had that 3-2 problem, so 6 is the lowest common multiple. So I'm going to put a 2 here. That'll give me 6. I'll put a 3 here. That'll give me 6. But when I do that, that 2 also applies to iron. So I need to go over here and make sure there are 2 irons. When I put the 3 here, it applied to the calcium. So I got to go back over here and make sure it applies to the calcium. Okay, everyone all right with that one? All right. Then I got 3 more like that I want you to try. Okay, so give those ones a try, see how you do. We'll go over them in a few minutes. Okay, so number 3 is a combustion reaction. Okay, that's the trick with that one. It's got all those special rules for balancing it, okay, when we're going over it. How do we know it's combustion? Well, we got carbon and hydrogen reacting with oxygen. Products of a combustion reaction are always carbon dioxide and water, okay, so definitely a combustion reaction. Now, the special rules for balancing a combustion reaction were, I balance in what order? Alphabetical order, okay, and then there was the rule of 2. Okay, the rule of 2 says if I have an even number of carbons, I start my balancing with a 2. Okay, I just do that automatically. So now I'm going to balance alphabetically. So 2 times 6 carbons is 12 carbons. So I need to go over here and make sure that I have 12 carbons. 2 times 14 is 28 hydrogens. Over here, 14 times 2 will give me 28 hydrogens. Everyone okay with what I've done so far? All right. Now I have oxygen left. Okay. The trick with oxygen is it is in 3 different places in the reaction. Okay. Once in the reactants and twice in the product. So I need to make sure that I add all the oxygens together. That's why there's a plus sign in this reaction. Okay, or in the chemical equation. So in the carbon dioxide, I have 24 oxygens, 12 times 2. And then I have another 14 here. Okay, so I have a total of 38 oxygens. Okay, there are 38 oxygens on the reactant side, or sorry, on the product side over here. So I need to make sure I have 38 of them over on this side, which means I need 19 oxygen molecules on that side, because 19 times 2 is 38. All right, now writing this out. Does anyone know what the prefix for 14 is? Tetradeca. Good. I didn't remember that. I was actually hoping someone knew because I don't remember what the prefix is for 14. Okay. I won't give you one that has that many in it on a test. Okay. That, or I'll just tell you that the actual name of this stuff is hexane. Okay. But yeah, you could say that this was, what was it? Tetradecahydrate. Okay. Yeah, I won't do that. I won't do that. Did you Google it, or did you just know that? Oh, okay. So you were just making it up. No, there's actually a name. There's actually, yeah, like there's dodeca, and then there's, yeah, is 12, right? Yeah. Oh, yeah. Tetradeca. There you go. Okay. I totally spaced on that one. Absolutely. Okay. Good stuff. We'll call it hexane. That's easier. I'm not writing that big long thing. Okay. Plus oxygen is what we've got here. Okay. And that's going to make carbon dioxide and water. What am I not doing with any of the names I'm writing? No capital letters. Make sure you're breaking that habit. Okay, every time you make a capital letter, slap your hand. I don't know, or something negative. Ban yourself from your phone for 5 minutes or whatever. Something unpleasant, so you'll stop doing it. How many people are done number 4? Okay, do we need a little more time on number 4? Okay, I'll give you a couple more minutes and we'll look at that one. Okay, so number 4, I start out with an element and it's reacting with another element. It's forming a single compound as the only product. What kind of reaction type is that? That's a synthesis reaction. All right, now, here's what I will often do when we get to the point where we're predicting the products of a chemical reaction. Yeah, we're not there yet, but this is what I often do. I often write it in this order, okay, where I put the non-metal first and the metal second. And then I see if people remember that that makes an ionic compound where we have to write the metal first. You'd be surprised how often I catch people on that little trick. Okay, just checking to see if you remember when I write an ionic compound, the metal's always first and the non-metal's always second, but it gets a lot of people because they forget. Okay, and I'm that guy. I'm a jerk, and I'll do that. Okay, so chlorine is reacting with lithium, and that is going to produce lithium chloride. All right, we got to balance this thing. Right now, chlorine is out of balance. There's 2 chlorines on this side. Now there are 2 chlorines on that side. That gives me 2 lithiums. So I got to go back here and make sure I got 2 lithiums, and I'm good to go. All right, let's also look at number 5 here, and then we'll look at how the other way these kind of questions can go. All right, I've got magnesium fluoride, which is an ionic compound, reacting with cobalt-3 nitrate. Okay, again, we don't want to forget to use the Roman numerals. And that's going to make magnesium nitrates. I'm going to run out of room. Okay, and cobalt-3 fluoride. Okay, just as a point of reference, if cobalt is a 3 on the reactant side, it's automatically a 3 on the product side. Okay, we're not going to switch from one type of cobalt to another from the reactants to the products. It'll always be the same kind. Okay, same with any of them. What kind of reaction is this? It's a double replacement. They're all ionic compounds. Okay, this is a double replacement reaction. All right, I need to balance it. The thing that's, I mean, there's several things that are out of balance right now. I'm going to go with the biggest number. That could be fluorine or nitrate. Doesn't really matter. They both have the same issue. So I'm going to start with nitrate. There's 3 nitrates over here, 2 over here. All right, we've already done that one, so I need the lowest common multiple, which is 6. So I put a 3 there and a 2 here. Now my nitrates are balanced. When I do that, that gives me 3 magnesiums. So I got to go back over here and make sure I have 3 magnesiums. When I do that, it gives me 6 fluorines. So I got to go back over here and make sure that I have 6 fluorines. When I do that, it gives me 2 cobalts. Always a good sign. Okay, cobalt I had already put a 2 in front of to balance the nitrates, so I know I've done it right because when I got back to that one, it was balanced already. Okay. Questions on how that one worked? It takes a little practice to get the balancing thing, but it's always that back and forth, back and forth. Very rarely do you ever run into a problem where you're like back and forth and you keep changing numbers and it never works. Okay, if that happens, here's probably what you did. You dropped and swapped something incorrectly. Okay, so if you're making up the reaction yourself, okay, and you're writing out the numbers, if you can't get it to balance, it probably means one of your drops and swaps wasn't right. All right, here's the other way that these reactions can go. I give you the reaction in words, and you have to write it out in formula form, so it looks like the ones we just did, identify the type, and balance. All right, so I want you guys to try number 6. Okay, these ones are tougher. Okay, they're tougher because if you don't get the formulas right, you won't get the balancing right either. Okay, and so that's the tricky part with these ones. We ready to give that one a look over? Oh, I was recording that whole time. There'll be a big pause in the middle of this recording. All right. So we got copper 2 nitrates. So that's going to be an ionic compound. So copper, and the Roman numeral tells me to use the copper with the 2+ charge. It's with nitrate. That's NO3. Okay, not N, nitrate, not nitride. And it's a -1. So when I drop and swap that, okay, I'm going to get that as my compound. Right? And now you can see, like, if you make one mistake in that formula, how are you going to get the product correct? How are you going to get the balancing correctly? It's just a mess after that. Okay. All right. That's reacting with magnesium. Just magnesium by itself. Okay. It doesn't say it's attached to anything. And that's going to form magnesium nitrate. So magnesium's a 2+. Okay. Nitrate's a -1. So it's going to be NO3 as well, just like on the other side. And copper. Okay, so again, pretty important to get my formulas right and make sure I do my drops and swaps, okay, and all that kind of stuff. Any questions on what I did there? All right, what kind of reaction is that? Single replacement. I have an ionic compound reacting with an element, okay, so it's a single replacement reaction. Now I need to balance. Done. Okay, it's already balanced. There's one copper, 2 nitrates, 1 magnesium, 1 magnesium. Sweet. Okay, always nice when you get one like that and you don't have to do anything. All right, I want you to try a couple more of those. Okay, so give those 3 a try. Let's see how we do on those. All right, so C12H26. We don't have to write the name for it because we're writing out the formulas, which is good. That's why I didn't write the name. Okay, we're just writing out the formulas for this reaction. C12H26 reacts with oxygen gas. What does that look like? O2. How important is it to remember the 2? Very. If you don't, you won't get the balancing right. You'll balance the reaction. Okay, you'll get numbers that work for you, but they won't be the right numbers because this is how oxygen appears as an element. Okay, so guys, that's why it's so crucial. Okay, if this is a 4-mark question and you make a mistake on one of the formulas, you lose 2 or 3 marks out of the 4. Okay, like really all you can hope for is you identify the reaction correctly and get a mark for that, because it just snowballs if you get one part wrong. Okay, all right, we always get carbon dioxide and water as the products for that reaction. Okay, do I have an even number? So I got to start with a 2. We're going to have big numbers here. All right, 2 times 12 is 24. So I got 24 carbons over there. Okay, 2 times 26 is 52. Okay, so I need 26 times 2 is 52 hydrogens over there. All right, now I got to figure out how many oxygens I have. I have 48 oxygens here in the carbon dioxide. Okay, I have 26 more over here. Everybody with me on that? That should be 74, right? Okay, so I have 74 oxygens. So 74 divided by 2 should be 37, yeah? Okay, so I need 37. I can't believe I did all that math in my head. That's dangerous. I shouldn't do that. I got lucky today. Okay. All right, so everyone okay with that one? And we said, what kind of reaction is that? It's a combustion reaction, so we'd have to label that as well. Okay, questions on 7. How are we doing on 8? Are we ready to go over 8, or do we need a few more minutes? A few more minutes? Okay, give you a couple more. Okay, let's have a look at number 8. So for number 8, I have lithium nitride. So that'll be Li with N. Lithium's a +1, nitrogen's a -3, so that'll look like this, Li3N. And it says it's breaking down. So there's nothing it's reacting with, it's just doing what? This is what kind of reaction? It's decomposition, so it's decomposing. Okay, so that means we're going to have lithium and nitrogen. Now, are either of those ones that require a small number? Yes, nitrogen always comes as a 2 when it's by itself. Okay, and again, that's one of those things we have to remember when we're writing it out this way. There's way more to think about when we're going from the word reaction to the numbers reaction. All right, so now that we have that, we got to look at how to balance this thing. okay? Because it's going to be a little bit tricky going back and forth. Okay, if I just say, oh, I'm going to start with the biggest number, and I put a 3 here, that doesn't help me to balance the nitrogens, does it? Okay, I'm going to put a 3 there and then go, oh, now the nitrogens aren't balanced. I'm going to have to erase it and start over again. And sometimes that happens, right? So what I'm going to do instead is I'm going to balance the nitrogens first. Since balancing the lithium didn't work, I'm going to balance the nitrogen first instead. There's 2 over here, so I'm going to put 2 over here. Okay, when I do that, how many lithiums does it give me? 6. Now the lithium's balanced too. Okay, and sometimes that happens. Okay, that start with the biggest number rule works like 98% of the time. This is one of the times it doesn't work. Okay, how many people have done number 9? All right, I'm going to give you guys a couple more minutes on 9 and show you 10. Whoop. And that should take us to the end here today. So we got hydrogen sulfide. So hydrogen with sulfur, okay? Sulfur is a -2, hydrogen's a +1, so we're going to be looking at H2S for hydrogen sulfide. Okay? That's reacting with calcium hydroxide, so that's Ca, and hydroxide's a polyatomic ion, OH. Okay? This is a 2+ and this is a 1-, so I'm going to have to use brackets around the OH on this one, okay, when I do my drop and swap. Okay, so it's a double replacement reaction. It's going to produce calcium sulfide. Okay, this is a -2 and this is a +2, so that one's already good. And hydrogen hydroxide or water. Now, here's a tip. Okay, a lot of people will see water and they'll write it like this, which is fine, except that when I write it like that, it's harder to balance. Okay, because it's harder to track where everything came from. Okay, what I do instead, when I see I have hydroxide on one side and I have water on the other, I write water this way. It's still H2O, but it's easier for me to keep track of where the hydrogen and the hydroxide come from when I'm balancing the reaction. Okay, so just a little tip, if you're dealing with a replacement reaction, this is a double replacement reaction, if water is involved, write it as HOH. It's easier to track. Okay, all right, so I can I'm going to start with the hydroxide or the hydrogen. It doesn't really matter here which one I choose first. Okay, there's 2 hydroxides here, so I'm going to put a 2 there. That gives me 2 hydrogens. Now I have 2 over here. Everything else is a 1, so I'm good. Okay, so it's a double replacement reaction, and that's what it should look like. Okay, and then our last one, phosphorus. Okay. Is phosphorus a special element? Yeah, very special. In fact, it comes as a what? 4 when it's by itself. Okay, when it's very special. Okay, so phosphorus reacts with oxygen, which is also special, comes as a 2, to produce triphosphorus, that's P3, dioxide, O2. All right, so this one will be a little bit trickier for balancing because we got lots of things to look at. What kind of reaction is that? It's a synthesis reaction. Element plus element gives compound. All right, so I've got 4 phosphorus over here. Best bet is to start with the biggest number. Okay, so 4 phosphorus and 3 phosphorus. What's my lowest common multiple there? 12. Yeah. All right. So if I put a 3 here, that gives me 12 phosphorus. If I put a 4 here, that gives me 12 phosphorus. All right. That also gives me how many oxygen? 8. Now I have 8 over there. Okay. How are we feeling about that? Okay, we'll probably spend a bit of time on that on Monday when we come back, not this coming Monday. And just to kind of review, because we'll probably forget a few things. And then by the middle of next week, we'll be working on predicting the products of a chemical reaction. We'll do our reactions lab middle of that week as well, okay, and kind of get moving along here. Okay. So I hope you guys all have a good, restful break.